Hey, this is Mr. Math Guy from Southwest High School in Minnesota. So I just want to go over standard deviation of the sum of two independent random variables. So might have went over this a little bit in your previous class, but might not spend enough time on it. So I just want to make sure we're good with this. If we do have, if we're adding two independent random variables together, to find their means, we just add their means. That's nice and easy, not too bad. But to find their standard deviations, to find the sum of the standard deviation of the random variables, we don't add the two standard deviations together. Remember, how we find standard deviation is we take the variance of the event and square root that. So we first need to find the variance of the event. I know you might have went over this last class, but just to kind of rehash. So if we have here, if we look at the event S, so what is the standard deviation of the event S? Which, think back to that, S was when you were adding Pete's number of passengers and Aaron's number of passengers. So we want to find the standard deviation of S. So in order to find the standard deviation of S, we cannot just add the standard deviations of X and Y together, because we have to first find the variance of S and square root that. So to find the variance of S, we need to take the variance of both of our random variables that we're adding together. So we got to take the variance of X and add it to the variance of Y. So variance, we know what the standard deviation is of X and Y, so we can just square those and then add them together to find the variance of the combined event of adding the two random variables together. So that would be 1.187446 plus 0.889249. So that would be our variance when you add those up. But just to save time, I'm just going to take the variance, and we don't actually want the variance. We want the standard deviation. So to find standard deviation, you would square root the variance, and then that would actually be our standard deviation of the combined random variables X plus Y. So which we are calling S. So that would be the standard deviation of S would be about 1.441. So that's how you find the standard deviation for when you're adding two random independent random variables. So remember, you can never add standard deviations. Never, ever, ever, ever. Don't ever add standard deviations. You can only add the variances, because you have to find the variance of the event first and then square root it. And it has to say they're independent. Remember, if they are not independent, it's not in the AP curriculum, but if you want to look it up, you could. So if they were dependent, you have to do something with like the correlation and how they're related. It's way more math. But we're only doing for two independent random variables. And if you think back to the examples, they are independent because Aaron is in another part of the country than good old Peter is. So we can assume they are independent. So this, I think, was the part in last class, or it might have been a little rushed, and there's a lot of students that were a little confused. When we are also subtracting random variables, we still would add their variances together. It's the same exact formula, and square root the variance to get the standard deviation of the combined events, which in this time we're doing X minus Y. There's two different reasons for that. The main reason is that the variation, if I'm subtracting X minus Y, it's still taking into account the variation of Y and the variation of X and the variation of Y. But if you're like, I don't kind of get that, I get it. I want to show you an example that's going to explain to you more why you still would add the variances together and not subtract them. So, this is not in the packet, but if we think of like ice cream, so for example, mint chocolate chip ice cream, obviously one of the best, and a cone. So first off, just gotta say this. Notice it's green mint chocolate chip. White mint chocolate chip is fake. That stuff doesn't taste as good. It has to be green mint chocolate chip. Obviously, I know everyone knows that. I didn't even need to say that. But so, for this example, we technically have two events here. If I'm trying to see like the weight of the total ice cream cone, we have the weight of the actual ice cream. So we'll say it's I is the weight of the ice cream, and we'll say the weight of the cone is C. So that's two different random variables when we have like a bunch of ice cream cones. Voila. And we'll say it's like one scoop for each cone. Each cone's going to weigh a little bit different. And each ice cream's going to weigh a little bit different because you might get a little bit more ice cream in one scoop. The cone might be a little bit bigger, a little bit more dense. Same thing with the ice cream. The ice cream will be a little more dense. So there's going to be range in the ice cream values. So let's say the ice cream values, it ranges from, I don't know, like 10 to 16 ounces. We'll say ounces. And the cone, a little bit lighter. We'll say the cone ranges from 1 to 3 ounces. So in order to understand why you add the variances instead of subtracting the variances when you're finding like the standard deviation for like if we're doing I minus C, I want to look at the range because I think it's easier to understand like how the range is being affected because it's just an easier like number to understand and it's a measure of spread, so it would stay a very similar case for a standard deviation. So let's look at the range. So if I was to find the range of I minus C, we'll do. We would take the largest number that we have for the ice cream. So the largest the ice cream can be is 16. So I take 16. And then the highest in the difference would be the highest I and then the lowest cone value. So the lowest the cone that we have is 1 ounce. So the highest in the range set would be 15. So it'll be 15. And then the lowest difference we could have would be the lowest I value, which is 10. And the highest cone value, because that's going to give us the lowest difference, minus 3, would be 7. So our range, if we were subtracting the two random variables, the ice cream weight and the cone weight, would be 15 to 7, or 8. And then let's see what would happen if we do the range of I plus C. So I plus C, the highest we could have for the, when we combine them, would be the two highest ones. So 16 plus 3 would be 19. And then the lowest would be, if we add the two lowest together, would be 19 to 11. And you'll see 19 minus 11, you still get 8. So when you subtract or when you add random variables, it doesn't change how you're measuring the measures of spread. It's going to be the same because the variation in I and the variation of C are both getting taken into account when you're doing I minus C and I plus C. So I hope that helped explain why it's the same for subtracting, but we'll do some subtracting examples now. So here's where it says standard deviation. It doesn't matter if you're subtracting or adding. Here's subtracting. You still add the variances and square root them after you add them. So I want you guys to try, look at, if you guys want to pause the video and try A and B, go right ahead and see how your interpretation is. But I'm also going to like walk through it too. So if we're looking at, so we're going back to examples of good old Pete and Aaron. I'm sure you're a little sick of hearing about Pete and Aaron right now, but so we're back to, so it's the money random variable. So we define the event of adding the two random variables as S. So we want to find the standard deviation of combining the two money random variables. So that would be equal to the variance square rooted. So to find the variance, I need to add the variance of C plus the variance of E, and then square root to find the standard deviation. Now, both these two numbers are from like back in the notes packet. We found them, but the standard deviation for C was 163. Oops. 163.46, and that's the standard deviation, so we got to square it. And then add 165.03, which was the standard deviation for Aaron's money. Square it, add them together, you're going to get the variance. But we want the standard deviation, so you would square root it. And from there, you should get, round to nearest cent, because we're talking money, would be $232.28. And the interpretation of that, so we first have to think, what is the event? So the event is the sum of the money collected by Aaron and Pete. So that's what we'll start with, the sum of the money collected by Pete and Aaron. So this is representing how far away each data point would be. So this is why it's important to say on a randomly selected day. So the sum of the money collected by Pete and Aaron on a randomly selected day. And what's standard deviation? How much it varies from the mean. So varies by about our standard deviation, which is $232.28 from the mean, which we know the mean. We could state the mean, but I'll just say from the mean. That's it. And the only thing about the difference, if you take a look at the next question, it says C minus C. So the only thing that's different about that, is not that much. It is literally the same exact thing, because we kind of like the ice cream example, the variation in S, C and E are still factoring into the variation of S. So it's going to be the same thing. You just got to change one thing. We're not talking about the sum of the money collected. We're talking about the difference. So we just got to write difference. That's it. On the next page, I want you guys to try this multiple choice question and pause it, play the video once you're done, and I'll explain. Correct answer for this one, be careful how it's worded. The only one that says on average it is about 0.28 away from the mean is D. So far we've concentrated on finding rules for means of variance for random variables. If random variables are normally distributed, we can use its mean and standard deviation to compute probabilities using normal CDF. So important fact about normal random variables is that any sum or difference of independent normal random variables is normally distributed. So that means if we are adding, say, we are adding x plus y together, and x is normally distributed, and we're getting s. And x is normally distributed, and so is y. That means s is also going to be normally distributed. So we can apply that and do normal CDF to the sum of x plus y if x and y are both normally distributed. So take a second, read this next question, and if you want to try it, go right ahead. It's a little bit tricky the first time you see it. So even if you guys want to try it, pause it and see what you get, and then check. Or I'll walk through it in like a second. So Mr. Sarnes likes between 8.5 and 9 grams of sugar in his hot tea. Very specific, Mr. Sarnes. Suppose the amount of sugar in a randomly selected packet follows a normal distribution. Glad to hear it. With a mean of 2.17 and standard deviation of 0.08. If Mr. Sarnes selects 4 packets at random, okay, so if we are saying P is so our random variable P would be the amount of sugar in a packet, so amount of number of grams of sugar in one packet, because that's the information they're giving us. If you could be like, why aren't we doing in 4 packets? That is going to affect the question later on. But the information they're giving us is right here. Suppose the amount of sugar in a randomly selected packet. So that's why I'm making that number of grams of sugar in 1 packet. So our mean of P is going to be 2.17, and our standard deviation of P is going to be 0.08. So if we have 4 packets, that means what we're trying to do is, if S is the sum of all of them, we would be adding P plus P plus P plus P. So there's 4 different random variables. They're all the same random variable, but there's 4 random variables we are adding together. So if I want to find the mean of S, what I need to do is I need to add the mean of P 4 times, because there's 4 packets. So that's really just doing 2.17 added 4 times, or it's really 4 times 2.17. So that gives me the mean of S, which is 8.68 is the mean of S. So that's going to be our mean in our normal CDF. Now I gotta find the standard deviation. So remember, we have the standard deviation of one packet. To find a standard deviation of 4 packets, so which I'm calling S, we need to first find the variance. We can't just add the standard deviations and then square root it. So we have to take each of the variances. So that would be, we have 4 packets, so we would add 1, 2, a third variance, and a 4th variance, and square root it. So you could plug in like 0.08 for each of them. That's really just, if you want to just like do the algebra, it would be 4 times the variance of P. So if you look at what the standard deviation is 0.08. So that would be 4 times 0.08 squared, which would be 0.16. So that would be our standard deviation of adding all 4 packets together. So we have the standard deviation, we have the mean. Now we can do normal CDF. Mr. Starnes, very specific man with his hot tea, only wants in between 8.5 and 9. Because all of our random variables that we're adding together are normally distributed, we know that S is normally distributed. So now we can do normal CDF. Mr. Starnes' lower bound is 8.5. His upper bound is 9. His mean, 8.68. Standard deviation, 0.16. Make sure you label. And plug that into the calculator, and you should get about 0.847 is the probability his tea will taste right. So that one, it's important to see that they give us the information of one selected packet. And then they're asking us for not 1 packet, but 4 packets. So that's why we need to find the mean of 4 packets. We have to add the mean of 4 each packet together of the 4. And it's the same thing for standard deviation, but you add their variances together and square root it. Awesome. So I want you guys to do the next 2 questions. 3 questions. There's another one here. So just do the next 3 questions, and I'll show the answers, and I'll kind of like go over like any tricky parts that I see coming up in these questions. So pause the video and play it once you're done. For this first one, it's all about what is the expected points per game. So it's not asking us for the moves per game. It's asking us for the points per game. But this information right here is in number of minutes. Minutes per game. But this information is a number of minutes. So we have to convert that into points per game. So in the card game, a player is worth 5 points for each card that is moved to a correct position, and is penalized 10 points for each minute. So X is the moves, Y is the minutes being used. So when I want to find the expected value of 9.5 moves, well, each move is 5 points. So that's why I multiplied 9.5 by 5. And then Y is number of minutes. So each minute you get minus 10 points. So that's why over here we do 5.4 times negative 10. So you're on average gaining 47.5 points, but then you're also losing 54 points. So when you add those together for the mean, you should get negative 6.5. So that's why it's either A or B. And then make sure when you find the variances, you just need to multiply the standard deviation of X by 5, multiply standard deviation of Y by negative 10. And then you don't add those two together. You have to square them to find their variances, and then you can square root it after you have their variance. So it should be choice B. The next one I think is tricky because we haven't done one exactly like this yet. We're not given the two random variables we're adding together. What we're given is one of them, the dogs, and then the combination. So this is like almost more like an algebra question than it is a stats question, because which is nice. I feel like we don't usually have questions like this. So you plug 98 in for the mean of the dogs, and then you plug 212 in for the mean of the cat and the dog, and then we need to find the mean of the cat. So you just subtract 98 on both sides, and you get the mean of the cat to be 114. And it's very similar for the standard deviation, because we're given a standard deviation of one cat and one dog is 39. We're given a standard deviation of a dog is 25, but we don't know the standard deviation for the cats. So we just leave it sigma sub c, or you can make it a variable if you want to, if it makes it easier for you to do. And then how do I get rid of the square root if I'm solving for sigma c? You square both sides, get everything on one side, so subtract 625 on both sides, and then square root in the end. And then here's the last one. Make sure you always add the variances together and then square root to find the standard deviation. That's it. Your homework's going to be that other packet. Make sure you finish it, and we'll go over that when I see you guys again next class.